Okay, naturally after learning integrals with our new techniques, use substitution or by parts, we move forward to definite integrals. So one method, just do the integral as you would and then substitute back into x and do the definite integral. But I'm going to show you a technique that, could save some time, be a little easier. So let's look at this first one. 2 multiplied by 2x minus 5 to the 14th. Remember, usually we let u be this inner function, or the ugliest piece. Kind of depends on the problem. Hopefully you've had some practice by now. So we'll call that u, and du then is 2dx. Another hint, remember that you're always trying to find a u and its derivative. So just by glancing at this, if I called that u, I see its derivative right there, the 2. So, okay, let's make this substitution. So now we'd have u to the 14th. Go and change colors here. U to the 14th. And then the 2 dx is now du. And here's kind of where you have some options. I prefer to change the bounds, the limits of integration here most often. Most often it would be easier. So what do I mean? Well, the original function, the original integral was all x, right? They're all x's, which means the bounds are x's as well. Now that I have u's, I can switch this to a function of u, an integral of u, right, with respect to du, and do the integration and never have to go back to x because it's a definite integral and I know I'm going to get some sort of number, right, as my result. So how does that work? Well, if u is 2x minus 5, right, let me go in and just rewrite this. If u is 2x minus 5 and x is 3, then I know I could substitute 3 in for x, right? So therefore u is 2 times 3 minus 5, which is 1. So when x is 3, u is 1. So therefore I'm going to change that 3 to a 1 and never return back to x. Do the same for 5 halves. So if x is 5 halves, then what would u be? Well, u would be 2 multiplied by 5 halves minus 5. 2's cancel. 5 minus 5 is 0. So the lower bound is 0. That is a very simple integral to compute now, right? And I never have to return to the x's. So u to the 14th integral, that is u to the 15 over 15, or 1/15th, right? From 0 to 1. So that's 1 to the 15th power over 15 minus 0 to the 15th power over 15, which I don't need to do that, 0. And 1 to the 15th is 1. And that's it. Okay, it's a little confusing. Check this video out, check out some other videos on YouTube, but this method makes the calculations pretty simple. Now, if we didn't do this, you don't have to, right? All of this, I was explaining how to change those bounds. If I went back to substituting u, okay, so there was my result, and I'm going to go back to x's, then I'd have 2x minus 5 to the 15 over 15 from 0 to 1. Right, I substituted what we have for u back into the result. Oops, not 0 to 1. Whoops. The original bounds for x, right, were 5 halves and 3. I would edit this video, but it's good to see me make mistakes, so I'm going to leave that. Well, you could already see, this is a bit uglier to compute. I'm going to pull out this 1/15th here. Now I have 2x minus 5 to the 15th, so 2 times 3 minus 5 to the 15th minus 2 times 5 halves minus 5 to the 15th. So it comes out relatively easy, but you could see, all of this in purple is, quite a bit uglier than just going to u. So this is 6 minus 5 is 1 to the 15th. 2's cancel. 5 minus 5 is 0 to the 15th. We have the 1/15th out front. So we just get 1/15th times 1. So you can see the results are in fact the same. Alright, let's do another example here. This again, u substitution is going to work. We always want to try that first. By parts, it's a little more work. Gets a little ugly. But if I call that u, the inner function, then du is 2x dx. So what are we missing? Just a 2, right? But we can't just put a 2 in, so multiply by half. And while we're at it, let's look at the bounds. So we have 3 and 5. So if x equals 5, then u would equal 5 squared minus 9. So 25 minus 9 is 16. That's our upper bound. If x equals 3, then u equals 3 squared, which is 9 minus 9, which is 0. You can already see I like those bounds better. Okay, so we have 1/2 out front, and our new bounds, the lower bound is 0, the upper bound is 16. Let's see, 2x dx is all du. So we just have u, right here's u, to the 1/2 power du. So that's 1/2. Integral of u to the 1/2 is u to the 3/2 divided by 3/2 or multiplied by 2/3. Okay, from 0 to 16. So the 2's cancel, we get 1/3. Substitute 16, 16 to the 3/2. So the 3/2 power, remember, means square root, that's the denominator, the 2 there, and then cubed. Okay, minus, well, 0 to the 3/2, I don't even need to rewrite it, 0 to any power, with the exception of 0, is 0. Alright, square root of 16 is 4, 4 to the 3rd, so that's 64, and then multiplied by 1/3, 64 thirds. Okay, again, you could never change these bounds and go back to x's for u and compute it that way, but oftentimes it's uglier, as you've seen down here. Alright, one more example. I'm looking at this, I don't see a u du, because, if u were x plus 1, du is 1 dx, and I have this x. So unfortunately, this is looking like it's going to be by parts. Change it back to black really quick, just to rewrite this. I could write it as x multiplied by x plus 1 to the negative 1/2. Alright. So recall that dv, we typically make this ugly part here, and u, we want the easy part, because then the u du, it drops off. So we're going to make u x, then du is just 1 dx, dv is the rest, x plus 1 to the negative 1/2. Now remember, we're integrating to get v. So the integral of this, technically we're using u substitution, but I could see chain rule here, right? The derivative is 1, so we're good to go. If you need to do this off to the side, you can. But let me write that dx. X plus 1 and then negative 1/2 dx, and then, do your u substitution from there. I'm going to just go in and compute it in my head. So I'm going to add 1, that'd be x plus 1 to the 1/2, and then divide by 1/2, so multiplied by 2. Now recall by parts, this setup kind of helps. You go uv minus vdu. Okay, uv minus vdu. So uv is x multiplied by 2x plus 1 to the 1/2 minus v du. So, and this is integral. Now, I still have all x's, right? So I'm going to go ahead and leave the 0 and 3. And in fact, this is the first time we did it by parts. This first part, let me go ahead and erase this. I need some room. Is evaluated 0 to 3, right? We did the integral because we're using this formula. So this needs evaluated from 0 to 3 minus integral 0 to 3 v du 2 x plus 1 to the 1/2 dx. Okay. So this left side, let's substitute 3. We'd have 3 times 2 multiplied by 3 plus 1 is 4 to the 1/2. Remember, 1/2 power is square root. Minus, well, if I plug in 0, 0 times 2 is 0, and then times anything is 0, so that's good there, 0. All right, back over here. We have another integral. Again, just like we did up here, the chain rule, right, u du is just 1, so I'm going to ignore that. This 2 I'm going to go ahead and pull out. So x plus 1 to the 3/2. I don't know why I wrote integral. We're doing the integral. I'm full of mistakes right now. X plus 1 to 3/2. And then divided by 3/2. So multiplied by 2/3. Evaluate that from 0 to 3. Notice I didn't change the bounds in this one. Personally, I don't care to do it with by parts. We already introduced a u and a v, and then we have du and dv, and it just gets messy. Ultimately, these all return back to x's fairly easy, so I just stick with original bounds. However, we could have done this one and, set our u down here and then change the bounds. Once in a while, this remaining integral will be easier to do the techniques that we just had done in the previous two. Okay, let's wrap this up. Substitute 3. So, well, I guess first out here we have, 6 times 2, so we have 12. And then minus 4/3. That was a multiply. Pen wrote, okay. Substitute 3, we have 3 plus 1 is 4 to the 3/2, so I'm going to go ahead and just change it like that. Minus 0 plus 1, so it's not 0, right? 0 plus 1, so 1 to the 3/2. So we get 12 minus 4/3 times 2 cubed is 8 minus 1, so 7. So that would be 12 minus 28/3. With an LCD, 12 would be 36. So 36/3 minus 28/3 is 8/3. Okay, just like the last video, I believe I had said by parts is typically the ugliest, and you could see as well with these two or these 3 examples it is. I don't use this u substitution to change the bounds most often when I do by parts, but I definitely feel it's helpful for the other ones, as in the first two